Okay, continuing on, I look at the next problem. Well, here we are. 1. Vertical asymptote will be x equal 1. 2. Slant asymptote or oblique asymptote y equal, since the top is greater than the bottom, that's an x squared minus x, subtract, and x divided by x is a plus 1. I'm done. So y equal x plus 1 is the slant or oblique asymptote. 3. The y-intercept, if I set x equal to 0, I will get a 0, because 0 over negative 1 is a 0. And 4, x-intercept, the top equals 0 when x equals 0. Remember, the origin is both the x and the y-intercept. Start with my asymptotes, x equal 1, that's a line for sure I can't cross. Y equal x plus 1, shift it up 1 unit, 1 up, 1 to the right. Horizontal asymptote, I cross roughly 15% of the time. I'm not going to be really concerned. You know what? I messed up that. That's okay. The graph crosses at 0, 0. Remember, so there's only one vertical asymptote, so this graph consists of two pieces. The piece to the left, if I start at the top, I'm going to have to cross the asymptote. I only do that when I have no choice. So I must start on the bottom, hit that, and head back down. Up would mean I'm going to cross that asymptote. The piece to the right, there's no way it could be this piece because there is no x-intercept there, right? So it has to be this piece. And there it is. Same deal here. I would factor x into x squared minus 2x minus 3 over x minus 2 into x plus 2, or that is x into x minus 3, x plus 1. Let me make sure I factor correctly. Yep. So 1. Vertical asymptotes, there are two of them, x equal plus or minus 2. 2. Oblique or slant asymptote, y equal long division. I'm going to divide right here. I'm going to take x cubed minus 2x squared minus 3x. Symptotic doesn't work on this because it's not linear, the divisor. So that's an x. Well, if I line them up, I know some of you get bothered when I don't do that. That is x cubed minus 4x. If I subtract, and negative 2x squared divided by x squared, that's negative 2. No need to go on because the remainder never comes into play. So it's always the quotient. There's the quotient. 3. The y-intercept, if I replace x by 0, put 0, I'm going to get 0 over negative 4, which is 0. And 4, x-intercept, where does the top equal 0? Too many points in this case. 0, 0, 3, 0, and negative 1, 0. Well, asymptotes, x equal 2, x equal negative 2. Y equal x minus 2, rise 1, run 1, rise 1, run 1. There it is. Intercepts, 0, 0, 3, 0, negative 1, 0. The piece to the left, I'm going to move this. Oops. Whoa. I'm going to move this so we can get a better graph. Here we go. The piece to the left. So remember, there are two asymptotes. There's a piece to the left, a piece in between, a piece to the right. The piece to the left has to be right there, because if it's here, I didn't get an x-intercept. The piece in between is very easy to get because it has to be at the top. The one part I'm not sure about, I know it's going to go back up. Does it go above or does it go below? I need a point between 0 and negative 1, say negative 1/2. I just want to know if it's positive or negative. negative. Negative 1/2 minus 3 is a negative. Negative 1/2 plus 1 is a positive. Negative 1/2 minus 2 is a negative, and negative 1/2 plus 2 is a positive. Three negatives will give a negative. There it is. And the piece to the right, well, it's going to start on the bottom because you need to go through that intercept and terminate right there. And there it is. Couple more to go. These are special cases. If I factor f of x equal x minus 1 into x plus 1 over x plus 1 squared. Well, we notice that this cancel with one of those. I'm looking at x minus 1 over x plus 1. Very good. 1. Vertical asymptote x equal negative 1. 2. Horizontal asymptote y equals, since the top is dominated by 1 and the bottom by 1, that's 1. I'm sorry, the top by x and the bottom by x, they cancel out. 3. The y-intercept, again, of this, let x equal 0, you get negative 1 over 1, which is a negative 1, and 4. X-intercept, where does the top equal 0 at 1? So if I start with my asymptotes, x equal negative 1, y equal 1, zero negative, oops, the color didn't pick up. 0 negative 1, very good, and negative 1 and 1 0. The piece to the left, well, it has to be up there. Hopefully by now we're comfortable with it because it can't be down there. I didn't get an x-intercept there. And the piece to the right. Now the fact that I canceled x equal negative 1. The fact that that's still there saved me the work of pointing that out. So this is the deal. If somebody's looking at this, they could tell x cannot be negative 1, but if you canceled it out, somebody would look at that and say, wait a minute, you have to show me that on the graph. In this case, no harm done. This problem, if I factor this, that is x plus 1 into x squared minus x plus 1 over x plus 5x plus 1. We know this doesn't factor in r. Notice that those cancel out. So I'm sketching the graph of x squared minus x plus 1 over x plus 5. That's really what g of x is. Now, 1. Vertical asymptote is x equal negative 5. 2. Oblique asymptote or slant asymptote, long division, on x squared minus x plus 1 over x plus 5. By the way, this gives you the same result. X squared divided by x is x. X squared plus 5x. Subtract. Negative 6x divided by x is negative 6, and there it is, the quotient. Always the quotient. X minus 6. 3. The y-intercept. Replace x by 0. You get 1/5. And 4. The x-intercept. Set the y equal to 0. The top can never be 0, so none. Now, x equal negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Rise 1, run 1. Rise 1, run 1. Again, I'm going to modify that. I'm going to move that whole thing down. Okay, well, for now, let's get this graph out of the way. I have an intercept at 0, 1/5. So the piece to the left, well, the piece to the left looks like this. And the piece to the right, again, the most basic graph that goes through the intercept starts next to an asymptote and ends next to an asymptote. Done. Not really. There is something we left out. Somebody looking at this graph, if you ask them what's the domain, they say x cannot be a -5. They're correct. But there's another value that you canceled. They can't tell from the graph. If x equal -1, what does y equal? On this graph that you're showing, -1, that's 1 plus 1 plus 1 over -1 plus 5, that is 3/4. At -1, 3/4, you have to show a hole on the graph, indicating that that's not in the domain. So somebody looking at this graph will know x cannot be a -5 and x cannot be a -1. So you show that clearly. Whenever you cancel out, anytime you cancel out a factor algebraically, now you're sketching the graph of this. Somebody looking at this graph will say, well, the only value you can't have is -5. That's that asymptote. You need to clearly indicate that I canceled out a factor, and that factor was at x equal -1. You figure out the point on this graph, and you make it a hole for them to know that this is not in the domain. Okay, I added another problem just to demonstrate this. Again, this turns out to be a big portion of calculus, first portion. So if I really work this out, g of x is x plus 4 into x plus 1 over x plus 2 into x plus 1. That cancels out. So 1 vertical asymptote, x equal -2. Horizontal asymptote, the top is dominated by x, bottom by x. So that's 1. Y-intercept, if I replace x by 0, I'll get 4/2, which is 2. And for x-intercept, the top equals 0 and x equal -2. So asymptote x equal -2, y equal 1. The graph passes through the point 0, 2 and -2, 0. Let me just make sure that is true. I'm sorry. That is -4, right? What is the top equal 0 at -4? So that should have been a -4 there. 1, 2, 3, 4. So the graph, well, this piece starts next to an asymptote and ends next to an asymptote. Everybody's happy. This piece starts next to an asymptote and ends next to an asymptote. Somebody looking at this graph will say, oh, we get it. You are marking -2. X cannot be a 2 because that's not in your domain. Well, do you notice you canceled x equal -1? Looking at this graph, there's no way of telling that x cannot be a -1. So you figure out where does, if you put -1 right there, it's going to be undefined. It's going to give you 0/0. You're going to put -1 in there to figure out what the y is on this graph. -1 plus 4 is a 3, and -1 plus 2 is a 1. At the point -1, 1, 2, 3, you're going to mark that as a hole, and you're going to label that point clearly, so whoever looks at this knows that x cannot be a -1 and x cannot be a -2. Alright, 2 more to go. It was really 1, but I added this O and I added G just because, we're cool and all. So I'm looking at this problem, trying to figure out what this looked like. G of x equal x squared into x squared minus 2x plus 2. And I know that this has no solution. X plus 1 squared. I'm talking about this. If you take x squared minus 2x plus 2 and set it equal to 0, x squared minus 2x plus half of the middle number squared, that's x minus 1 squared equal -1. No solution. So this has a vertical asymptote at x equal -1. Good. 2, we have an oblique or a slant asymptote at y equal, I'll get that in a minute. 3, y-intercept, set x equal to 0. If I put 0, wouldn't that be 0 over 1, which is 0? And I need just a bit more space. And where does the y equal 0? The top equals 0 when x equals 0. That is my x-intercept. Oops. Remember, the origin is both the x and the y-intercept combined. So if I look at this graph, this is, well, let's take x to the 4th plus 2x cubed plus 2x squared divided by x squared plus 2x plus 1. That is x squared, x to the 4th plus 2x cubed plus x squared. Subtract. That will be x squared. X squared divided by x squared is 1. So that is y equal x squared plus 1. So it's not really an oblique line. It is a parabola. It's a parabola shifted up 1 unit. So it looks like this. I know it looks really odd, but these are actual graphs. There we go. So the red we don't come close to. We get very close to, but we never reach. Now the asymptotes are going to save, the intercepts are going to really give this graph away, 0, 0. Well, the piece to the left, there's one vertical asymptote, you guys. So either the graph starts on the bottom, but I can't cross the x-axis there, so it has to start on the top of this asymptote and terminate next to that asymptote. And the piece to the right, if it starts here, do you see that I need to cross the asymptote to reach that 0? That's unlikely. So I'm going to start next to an asymptote, go through the intercept, and end next to the asymptote. Not a typical graph, but it's all good. And this is a bonus. I just thought this was kind of a fun graph, and it has a nice application that I'm sure you're going to run into one of them days. So if I want to sketch a graph of this is fairly quick. 1, vertical asymptotes, none. The denominator can never be 0. 2, we have a horizontal asymptote, y equal, the top is dominated by x squared, the bottom by x squared, that's a 1. 3, y-intercept, if x equals 0, 0 over 1 is 0, and that turns out to be the x-intercept as well. If I set the top equals 0, that is at 0. So my graph passes through the point 0, 0. There is one asymptote at y equal 1. A graph starts next to an asymptote, goes through the intercepts, and ends next to an asymptote. And this is, if you notice, that's an upside down bell-shaped curve. I could rotate it by multiplying by a negative and shift it up. That's what is known in statistics as a normal distribution. Massive deal for stats people. For us, we graph it, we move on, and we're done. And that's pretty much it for this section.